Okay, so welcome to our seminar series. So this week we are glad to have Alex, our new faculty, to give a talk on the main data networking of things. Alex actually currently just joined as I said, just joined our school as assistant professor. And previously he received his PhD from UCLA in 2013. And he's been working in the NDA group at actually UCLA and doing a lot of amazing things. And he's very interested in information-centric networking and Internet of Things. So today he's going to talk about his research interest in it.
And if there are students, like there are a few who are interested in this area, I'm also very, very interested in working with it. So that's one part of advertising. So besides this nice name of the talk, my main objective is to reintroduce named data networking in general for people who may be not really aware of what it is and how maybe some few details how it's working. Plus give some glimpse on how this actually merges with the things of the Internet of Things. So before I go further, this is just some idea of how the current Internet, how the current technologies are operating. So this is a standard hourglass shape as defined by the RFC 793, if I'm not mistaken. So it has a kind of foundation of this hourglass is IP protocol, which is kind of based on various types of link layer technologies. And on top of that is a nice layering mechanism, layering structure of communication. And network, for the application perspective, is operating as a kind of black box. It's pushing packets toward the destination. The global connectivity is again organized as part of this IP layer. There's a global routing that kind of knows where all those IP addresses are located. And the picture is nice. IP is really great fundamental framework for the networking, at least as it was designed. But there are a few kind of caveats in this overall picture. Is that we don't really, when we run in the applications, we don't really deal directly with the networking, and there is some big semantical gaps between what the applications are doing and what the networking is providing. So specifically here is application and networking actually in many cases operating in completely different namespaces. So like application, if you know something about DNS, maybe it's even going forward like message queues or structured message queues, which are all translated into the ports and IP addresses underneath. And why it matters? Because it introduces, first of all, it introduces complexity, and the second is it's actually not giving the applications all the controls of this app, all the controls that it may want to have over the networking. And then on the flip side, networking may not be able to take all the advantages of what application semantics. Let me give just kind of add in a few words about all those dependencies. So even though you have a simple application to request if we had some AirPlay or some other technology that not directly connecting it. So if I wanted to project my presentation on a connected projector, so both of us would need to get an IP address, like rely on some form of HTTP service. We may or may not want to rely on DNS service. In some cases, it would be MDNS to figure out what is the IP address of that guy. And finally, have some form of connectivity. I was trying to say something. Different namespaces. Give me a sec. Okay, I'm blanking, but there was one important part that I would highlight about dependency. Okay, blanking on this one. So that was the kind of all the current state of the art. So we have this even with different namespaces, but we're trying to operate in those namespaces. And the thing I was remembered what I want to highlight is that network don't have all the application levels semantic understanding what application wants. So network cannot really help application in in some cases. And to give you an example, firewalling. So kind of network, we want to assist application to not propagate certain type of data beyond the network or prioritize certain quality of service, voice traffic over other traffic. Right now, network can try to infer something from the port numbers, maybe from some deep packet inspection, but they kind of not given the applications separated from the networking, and those two operate in independent domains and kind of not in concert with each other. So that's a problem. And the solution was Van Jacobson introduced the kind of idea of content-centric networking or main data networking, information-centric networking. There are similar terms with the slight variations. And if you're interested, there's a very nice kind of old presentation. And to follow up, we have a bunch more of tutorials that you can get on the NDN website that I will show as part of the last slide. So, what is the idea? So, what we're trying to do, or what we're kind of trying to introduce with the main data networking? The idea is to keep that hourglass shape of the internet architecture, still have one foundation that will kind of drive all, build be a networking layer for every application and be on top of any type of link layer. But instead of focusing on this small packet, instead of delivering packets to whatever single destinations that we focus on the networking today, is to switch to the retrieval of named pieces of secure chunks of data. So it's still a small pieces of kind of still packets we're trying to retrieve from the network, but then they just each packet that first of all, it's a retrieval. So instead of sending, you retrieve something, like asking the network, oh, please give me this piece of data. That's one, and every single piece of data is effectively secure. It doesn't matter from where it's coming from, whether it's in cache, whether it's processed, whether it's...
So you are trying to argue location is not important.
Yes, yes. So in NDN, we're trying to build security into the data, not into the channel. So you don't really need... You may want to build this concept of a channel if you have this point-to-point semantics for the application or for the bank transactions. But for the majority of... Okay, I should not make this generalization. For classes of application, we not have the concept of point-to-point connectivity. So for example, news website. You may just want to request, I want to get the new CNN.com page right now. Like, this is what I want to do. CNN page for today news. And that's what you're interested in. And you don't really care is it coming from East Coast, West Coast, Japan, or local cache and not local cache. If you know that this is what you want to get, when you got the result that it's secured, this is the piece of data that was actually produced by CNN. It was produced today, or whatever, plus minus a couple minutes. Then that's it. So kind of networking will try to help you to get the
duplication of data. With the data which are sort of identical or similar, then how do you sort of define the namespace?
So that's a good question. This question is probably related to this information. So that, in a simple word, that would be out of scope the networking architecture. So there's still somebody who's producing data, and that somebody has a own specific namespace prefix. And I'll give you a few examples of what the namespace, at least part of it could be. That kind of website or like the entity producing data under that namespace. That data can be similar to some other news outlet data, but that would be outside the scope of the network. There's actually a few interesting projects that my colleagues were working on. It's called the information maximization. That was kind of semi-military application where they want to put multiple entities in the field, taking pictures, taking some samples of the environment. And the objective is that there's some data mule walking around the city, and they around whatever battlefield or something, and trying to get as maximum of diverse data as possible, and diversity defined in terms of namespace. But that's just a little bit of sidetrack of this one.
Before you go on, when you say secure, in what sense do you mean secure? It sounds like you mostly mean authenticity.
Yes. So I have a slide a little bit later about this specific point.
All right, then hold it for later.
I hope we can get to that point, but just to highlight, notice authenticity is a foundation block for security. You can build other types. You can add the secrecy on top of the authenticity, but authenticity has to be present in some form. There's also more questions about privacy, which is actually a little bit less defined for the data-centric architecture than for session-centric architecture, because we can have a separate conversation. I'll try to keep a few minutes at the end so we can have this discussion. Okay, let me skip this one. So the idea is that moving this narrow waist from the packets to the data packets. And this is just an idea. To have this semantics of data retrieval, we normally can have just one packet, because you have to have a packet for the request and packet for the actual response. And this is just a high-level example. So there's an interest packet or request packet, which is expressed by the consumer to the next router. This next router evaluates this packet and proceeds further. Okay, let me try to speed up. Oops, wrong direction. So the idea with this change, and I'm trying to get to the point of the names to show you examples, is there's actually no longer need to do several things that exist in current IP architecture. So for example, there is no longer need for the DHCP server, because as long as you know in which namespace you're producing data for the publisher perspective, and you have public private keys and certificates, you just publish data and you kind of respond to the requests that are coming from, and that's it. And if you're a consumer, it's even less problem. You just need to express your interest, and that the interest will be forwarded inside the network to proper directions and retrieve your data. I'm kind of skipping a few steps in this picture, but on a high level, this is kind of what we're trying to achieve. You don't need to bootstrap yourself. You don't need to give your IP address. You may need to bootstrap which router can forward the request, or in which environment you want to forward the request. But that's a separate story. You don't really need the DNS servers, because the network operates on the namespace that that application operates on. So the congruency of the namespace now. And the most important part of this picture is that applications no longer, in many cases, require this stable connectivity to point-to-point connectivity, because data can come in kind of DTN-like delay-tolerant fashion. So you express interest to the router, you may wait for some time. A router may, again, express interest further or to one direction. It can actually express interest in a couple more directions in parallel. Again, wait a couple of times to re-express that interest. So, and the consumer can again, at some later point of time, re-express that interest. So, and you will get data eventually. While in IP model, you always have to send packet to destination. You have some form of virtual connection to that destination, and you always talk into the destination. Again, there's a few caveats in the statement, because there are a few new protocols that are trying to relax this requirement of a specific destination, have to introduce the concept of migrations of the connection. But again, all of this just highlights that there's a problem of this point-to-point connectivity. In our mobile world, when we're moving from one network to another network, when producers move from one network to another network, or even in context of CDNs, content delivery networks, our data that we're actually interested in is not in a specific place. It's scattered around for the various purposes. And this is kind of to highlight in summary of the whole NDN picture. that can be just highlighted with the three basic blocks. The important part, is that each piece of data is being named, that each piece of data is secured, that mandates the authenticity properties, but also can include the secrecy confidentiality properties. And another important piece of the completeness puzzle is the stateful forwarding. So, in order to avoid, or in order to implement the scalable forwarding, I apologize, there's more errors available on this slide, and I'll rephrase it. So the first two blocks, so naming data and securing data directly, actually enables the data immutability, which in turn enables that you can actually cache that piece of data anywhere and retrieve it from anywhere in the world, and that would be sufficient to get that information. You can do DTN-like communication, you can quickly recover from losses. At the same time, the naming data and stateful forwarding plane, which does not depend on the source addresses anymore. So there is no source address in this interest packet, but rather each router remembers who requested some specific data. You immediately get the benefit of having the multicast. And in both in terms of immediate multicast and kind of slightly delayed multicast with the help of the caching. What else I have here? With the forwarding plane, with the stateful forwarding plane, you no longer rely on this TTL field and packets to kill the loops in the system, but rather have inherent in-network avoidance of the loops effectively. You can pick the same place where you send the interest before, but you can quickly change the direction and kind of avoid that loop. So that actually enables the multi-pass interest forwarding. So you no longer now have to directly follow the routing system as it is defined, but rather you can take routing system as advice. That's saying that, so the routing system saying that this direction and that direction gives you the most optimal path to reach that data. So let me try the third one, because I think the third one is also potentially direct. So that one, I have a little bit more details on this node and the forwarding module a little bit later, but not sure if we're going to have time for that. But this is idea for the so-called forwarding strategy. And there are several ideas how those forwarding strategies can operate. They can operate in different namespaces. And I think I have a few more things. So, kind of securing data, and again, with the help of stateful forwarding, you can actually avoid bad actors in the system. So if you went to do like this first route, and what you got back was some malicious data, or some data that you don't actually, the consumer consumers don't really like in some way. So then you can send another request, and the router can try to pick another alternative path to retrieve data and effectively go around that bad node. Okay, scalable, secure, and resilient data. And so finally, I should have put this slide a little bit earlier. So I want to highlight that a lot of things in NDN and information-centric networking and named data networking specifically is all about names. So the names. So NDN advocates, or NDN introduces or reintroduces actually these hierarchical names that the first part of the hierarchy defines some of the context of this data. So it can be, sorry, UCLA slide. I thought I changed it there for you before. So it introduces some context of the data, and then there's some other components that are human readable or not human readable. They just have some semantic interpretation for the application that can be interpreted by the network routers as well. So I gave you a few examples on this slide. So it can be just the actual data, like the raw frames of some captured video, or the slide deck, or segment of the slide deck, chunk of file that represent the slide deck. But it also can be a command. It's a command as part as a data packet. It can be a response to the command in cases when you want to have a command as part of the request. So that you send a request to somebody with the side effect that produces a status result, and a few other things, including the cryptographic key. So everything is kind of built within the same architecture. Everything is a named piece of data. Everything can be named piece of data, and the name hierarchy defines some form of a context used both by the application, by the routing, by the application, by the networking, and for the security purposes. So this actually, it's a nice concept of every application in networking and security uses the same namespace, but at the same time it introduces a few challenges because now application developers or the guys who are deploying this application has to be aware that you need to define the namespace that kind of play nice with the networking. At the same time, it has meaningful for the application and meaningful for security concept. And for the last part, we're trying to come up with some naming conventions or some standards for the naming conventions to simplify the development of the applications in that sense. And to give you some highlights of what naming can achieve, and I think already alluded to this one, is that you can do basically zero configurability or zero configuration and very, very easy auto discovery process. So if I was in a local environment that supports NDN natively, so the only thing I would need to send my presentation to this projector in this room is to send some form of a request to this broadcast domain where projector is connected. And that projector or projectors, because we have two in this room, would display what I want them to display without introducing IP addresses, without doing any kind of DNS. And if there's a security trust anchors properly configured on those projectors, and I have a proper authentication or proper certificates, all this communication will be actually secure. What else? There's just a few small random things about the seamless ad hoc communication. So for the ad hoc communication, you don't really need to introduce any new protocol. So the only thing, there's no new routing protocol with ad hoc and VPN protocol. So this one just highlights that, let's say some student on the campus take a picture of a printer, some building like this somewhere. And the visitor coming to campus and he has some direct Wi-Fi direct or Bluetooth connectivity with that person. He just expresses the interest of give me some information about the FIU SCIS. At the same time, he can also ask the same question to the same person or somebody else, what is the traffic information? And if that person has this information, it can directly give that secure piece of data back to the visitor, or there could be forwarding strategy to relay that information further, or just give nothing and there will be another attempt to get from another encounter with somebody else. There's also possible to do with named pieces of data and named pieces of secure data is to integrate not just networking and storage in the form of caching, but also seamlessly integrate the processing. Because you can not just name the data or name the commands, but you can also name the function and results of the function that you want to achieve. So you can say, I forgot what exactly, requesting the SLAM algorithm processing on this subset of data. So in effect, we just express an interest, the first part is just the name of the function that they want to express, plus some more arguments to this function. And then this request would either go to some local storage that already has the process data, or it will be directed to like CPU processing somewhere or FPGA processing if there are some FPGA units deployed in some environments, like in localized environments. And again, this one I already highlighted, but just again, with the naming, with the securing of data, it's also possible to use all available interfaces at kind of either at the same time or selectively use those interfaces at this, based on some policies. For example, the phone may decide to use only Wi-Fi and Wi-Fi Direct to request the function processing or serve as a process, serve as an entity to process data in some form, and use LTE interface only to request very critical information or not that big information. Okay, so I'll stop for a second, and ask whether you have questions about NDN or picture of NDN, because I have a little bit different type of slide afterwards. Yeah.
One question is ordering of the data and understanding if components of the data, parts of the data are lost in transit and so forth, the kind of thing that TCP does in our world. How is that handled?
So that would be, so everything is part of the name, and the naming conventions define how big piece of data is split or chunked into multiple pieces of actual packets. And you're requesting the first segment, second chunk, third chunk. And you, but as a consumer, you would always know what exactly you have lost. But to answer your question like in a slightly different way, so of course we would need some form of transport-ish like functionality, but it doesn't have to be built in into the kernel of into the operating system. There is no need for additional port numbers to dispatch that request to a specific application. It's rather all this information is built into as part of the name, and name can be directed to a specific application and libraries and routine inside the application to realize that function in a consumer-driven fashion. And one second. And that's kind of similar to what people are trying to do right now with the quick. Like they don't want to deal with TCP because TCP is so hard to change. But they want better transfer protocol between Google and Chrome browser. So they build it on top of TCP because there's no other option for them to actually do that in some reliable fashion. Yeah.
Okay, so so the NDN has been pushed for a while as a general thing. So one criticism of NDN is it seems to be that you build a lot of things inside the network, so having the network be able to be very intelligent about things. And from the user perspective, it's convenience. However, it's very difficult for you to see what's exactly going on in the network. Right? So there's name resolution, there's data caching in the network. Somewhere there will be data is cached. Somewhere my authentication is taken place, and I have sort of, from an end user point of view, I have very little control of what's being viewed inside there, and be able to sort of manipulate, the caching decisions. For example, I know something which is not necessarily somewhere else. I will try to bypass this sort of NDN infrastructure. It will be very, very difficult for me to do so. And not like IP network, I would like to know about exactly what's going on there. So
I mean, even in IP networks, you not necessarily know what's going on. But I want to have a different comment. You're not really talking from the user's perspective. You're probably talking from the network manager, from Eric's perspective.
Not necessarily. I could be a developer. I could be doing my application, and actually for the sake of the performance of my application. And how much control would I be able to? I know that end user just want to check news. It doesn't. They don't necessarily actually need to know exactly where things are coming from. However, for the networks built on innovations in there, it seems like here it is, and take it.
So you highlighted a very good problem, and right now there's a ongoing effort to build quite a bit of network management functionality as part of our prototype implementations. We're still not there, but we really want to, from our application developers, from the network management perspective, you may want to know more about what is happening. Like it's actually a different way from the IP perspective, because in IP, you want to know what is how to route, whether you can route a specific destination host. And that path is most likely a single one, and sometimes you can get diverted in different directions. But in NDN, you would want to know how the interest actually forwarded. And for different interests, it would be forwarded in different directions from different caches satisfied. So we're actually working on this. This is very, very recent. The problem is old, but we finally got time to work on this problem to actually understand it. And kind of one of the ideas how to deal with this problem is to have some form of a tag, but you can optional tag this request, and the routers will kind of interpret these tags and can record additional information that can be piggybacked on the, both on interest sending out and on the data packet coming back. Again, this is brand new stuff. Somebody wants to actually do development on this. I'm looking for some students that are doing some mobile phone applications. Things. Okay, they didn't get that message. But okay, I'll stop here. And now for the authentication, most of the authentication is actually going to happen at the consumer side, because the only consumer most likely would know what is the proper trust model to trust specific piece of data. I'm going to get to the point of the trust schema that I actually mentioned during my interview talk, that you can actually define trust model as far as using name relationship. I'll try to get to the point, but just a highlight. And then package those set of name relationship and how name of data, name of the key that signed the data should be related, and you can package it as a data packet and deliver it to somebody else, so that person can and cannot verify. But how to know whether he actually did that verification?
Right.
That's
so just to add the criticism actually, for IT network and creativity innovations being used on layer. I guess the question eventually comes down to, NDN is one of the solutions, or there are other solutions, right? So you can debate which solution is better, but there are always later on new functionality introduced or new type of
as part of the networking or as part of the application?
and information just in terms of how the information is actually transferred. So there are always going to be new things coming in. How open, an architecture like NDN would be able to sort of open up to sort of new ideas. Say I have a different caching algorithm, right? And I like to use my caching algorithm. Is that possible using, like NDN?
So there could be multiple answers to this question. If you own some specific router and you build in that router and that you think that this is the way of doing business, of course. That's a caching decision is totally local to that specific NDN router. Whether you can ask somebody else to follow your decision of routing, even you don't have a full control of that data node, that's a question, and probably beyond the architecture. It's more like ownership and how you, what is the relationship between you and that node. But what NDN is trying to do is create some building blocks that hopefully as minimum as possible for to realize this request response networking model based on names directly. So other things can be built ideally in an application level somewhere else, or if needed, added to the architecture, not architecture, added to the router framework somewhere. So hopefully NDN is kind of ground truth, like very, very basic like element on top of which all the innovation will happen. So that's kind of goal and idea. Yeah.
Just another question, and I'm just trying to, as an old networking guy, trying to wrap my head around the whole thing. Where the old networking paradigm is one of client server, it's going to sound the same, but I think it's fundamentally different. The new paradigm is more along the line of requester producer.
Actually, not that. Requester data.
Requester.
Yeah. So that's a very good comment, and I think we call it the prosumer model, like a producer-consumer, where data is actually in the middle and acts as this intermediary. So consumers don't actually talk in a logical way. They don't directly talk to the server. They try to request the data. And producers don't necessarily know who requests and don't talk directly to the consumer. They just produce the data. And that can happen at the same time. So that request reaches the producer and given back immediately. But it also allows this separation of lifetimes of the both. So kind of data acting as intermediary. So consumer and data has to live at the same time. Producer and data should exist at the same time. But producer and consumer or consumers are just different. But I think your point is that NDN actually changes the way you look at the network. So it's very different. It's really different from the server client server. So there's not really client and not really server, but rather producer and consumer separate are available.
Address this right now, but what I'm in my mind trying to wrap myself around is an NDN model for an encrypted SSH connection between two cloud systems. And I think if I can understand that, I'll really get NDN, but I don't worry about it right now.
I will not worry about it right now, but I just add, if there are some applications that have inherent point-to-point semantics, and you can always implement that semantics on top of NDN. Whether it would use all the benefits of NDN, probably not, but it's always possible to implement SSH. You actually have to do that. So this part of, again, we started with that conversation recently, but don't have enough manpower to realize those concepts because it's not that too interesting to do, but not much research. You just need to realize it's just mechanical work of implementing SSH on top of the internet gateway.
I just think from the point of view, if I could completely understand what's going on in that NDN world, I would have a better understanding.
Yeah. Good question, but let me move to the actual talk that I promised to do is the things. So I covered name data networking, and then now I'm getting to the things part of the name data networking. So I already highlighted those things. Those elements are many of today's IoT solutions are actually inherently point-to-point, even though they kind of don't seem on the surface that they point-to-point, but they really are. And with the worst to the overall picture, they're cloud dependent. So for example, I have Nest at my home, and when I'm physically near home, like I can adjust the knob and correct it. So that would be ideal area when I'm physically doing it. But when I'm with my phone near the device, because I'm lazy to stand up and actually turn anything, that request doesn't go directly. So that request going to the cloud, and cloud may or may not authorize to my command to my Nest at my home. Okay, this is what all I want to say about this part. And add on top of this is the Nest has to get the local IP address. This Nest has to figure out make the DNS lookup for the cloud servers, somehow register on that magical cloud service as a Nest belonging to me, and then the same operation has to happen with my phone. So there's a lot of complexity, and I hope I have a slide of this one. Highlighting the current structure of IT applications, like the layers and layers of different stacks. IP, for example, UDP, DTLS, CLAP, and finally we get into the point of the application. And remember, only like application, and actually here there's also potentially a couple of layers of like a messaging bus introduced and so forth. Okay, I'm not going to go over the example, but that's, I already kind of highlighted it. There is quite a bit of problem to do a very, very simple operation. And the selling point of NDN for edges, okay, I'll rephrase a bit to preempt maybe potential questions. So one question was like generally asked is when we're going to have NDN deployed, like or replace IP. That's a very good question with a not really good answer. We are, I don't know, how many years in deployment of IPv6 and we're not moving anywhere. So one of the reasons we're not really moving anywhere, there's not really urge to switch. IPv6 doesn't introduce any new capacity, new like fundamental new things to build system. So changing something that is working, that could be complex or sometimes impossible. So the idea that we're trying to pitch, I'm trying to pitch, is quite a bit of environments where IP solutions don't work, or they just very, very ugly, like the one I just showed you in IT infrastructure. So yes, we can build some Nest and IoT environment sensing with IP by sending packets, but then we just add in a few layers and we're losing some flexibility of doing cross-layer optimization using multiple interfaces, like really relying on geolocation to forward the request. But the NDN allows kind of have a few has an edge to actually realize this one. And beyond that part, there's a few interesting concepts that actually NDN can bring, because NDN as a networking layer operates on application names. So you're no longer bound to talk to the controller or whatever IoT thing as a device. So you no longer need to kind of, this is thermostat, this has an IP address, let me get to the controller and then issue some request to get the temperature. But rather you can just ask the question that you want to know. Like, I want to know the temperature in this room. Like coupled with local discovery, that's all that application needs to know. And that's all the controller needs to do is to receive requests for the temperature and tell, oh, here's the temperature. It doesn't have to be that specific controller. It could be the other controller or this controller or all controllers at the same time. But so the alignment of the networking and kind of application semantics, you don't have to change when you develop an application or developing kind of a framework of IoT framework. You don't have to think about devices, but rather temperature, cow, like if it's like a heart rate of the cow, if you're talking about smart agriculture or smart farming. Okay, let me move a
It's
little bit.
maybe sort of application dependent, right?
Yes, so it's really application dependent, meaning that application has to have a networking considerations, and both networking has to have application considerations to actually make it a very nice, very efficient way of doing business. So this is just to highlight how picture simplifies in NDN framework. We just have the concept of the data packets, and you send request, and you get the response back from whatever place possible. I'll try to go a little bit faster to get to some interesting point. This is just a few interesting highlights of how to communication can work. And as I said, when you're inside the home, inside some environment, that request can directly be broadcasted within the home, and you get the response back. If you're not at home, that request can go through the network, and using the name prefixes instead of IP address prefixes to forward this request towards that destination, potentially using multiple alternative paths, going around some failures or bad nodes, bad actors in the system, but eventually getting to the point of the network. one thing that I want to highlight with this slide is forwarding tables are very much similar to IP routing tables. It's just a different namespace. So now, instead of using separate namespace just for the routing purposes of the IP packets, NDN uses the same namespace to forward the request to the data. There are a few caveats to this statement, but I'll omit those. And okay, bring it home. This one, they just highlight that with the concept of secure data, you can have a secured personal health information, and it would be owners of the data to decide with whom that data can be shared. So this actually has a very good relationship with the confidentiality of the data, but I'll share with slide deck with whoever wants to get it. Are we going to post it somewhere? Okay, so the slide deck includes more stuff that I have talked today, but you own the data, and you not just giving this data to anybody, but rather you give it to the person that you know that should read your data, for example, to your doctors or your friends.
So I wanted to follow up a question about this. So the data has different needs, right? So just using this picture here. So if I want to know my own heart rate, right, and I do have a watch or something, I can actually find out right away. Yes, I have a body area network which I can really be able to access data right away. And on the other hand, the data can be actually forwarded to a data bank, right?
Yeah.
My health bank. So, and my doctor will be able to see it. And what I meant here is, it's application dependent, as you mentioned, because it depend on what type of applications you want to consume the data, whether it's for checking my heart rate right now, because there is a real time to it, or it's just for historical records. And how do you sort of be able to sort of have different requirements, different demands, sort of embedded into NDN, so that as a producer, I will have data for satisfy different needs, and I have to know that beforehand because I know that I need to send my data to some cloud or something, or to store it temporarily locally. So how do you actually be able to sort of satisfy these kind of diverging demands that might come to your system?
Okay, so this is a very good question, and I have two potentially related answers to this one. So one is if the data is kind of secret or confidential, it by definition is kind of encrypted. So the content is encrypted, and then the question is kind of to give access to this data is a proper distribution of decryption keys. So we have a mechanism called name-based access control to try to utilize, again, naming conventions to both define what kind of access you want to give, what namespaces you want to give access to a specific people. But again, that would not be a full answer to the question because you're saying there are two different types of data. There's a kind of real-time produced data, and there may be some data that is additionally processed and for the archival purposes. So there's actually a very recent paper at the ICM conference where they defined what's called the schemata for data confidentiality. So you as an owner can define a policy or set of policies saying that this high granular data is only available to me or the very trusted processing unit, processing box that I own. But any other data or the processed data or data with a lower granularity can be accessed by a larger pool of people.
So I guess what I meant is how do you determine those kind of dynamics? Because I could, sort of the data could be used, and I'm not talking about my personal health data, it might be the room temperature, stuff like that. And it could be used by people inside the room to decide that what is the comfortable temperature. On the other hand, it could be decided by someone, energy producer, sort of like trying to understand what the energy consumption of the unit. and try to sort of get historical prediction. So it depends at that particular moment, or whatever application decided to sort of.
So I would say it doesn't depend on that particular moment, but rather it depends on who owns the data and some identities. So you can decide to share data with or share a different granularity of data with other people at a later point of time. So you don't have to decide at the time of production. So because you logically separate the guy who produced the data, like smartwatch, and you as the owner, the logical owner of the data. So high-level answer is you don't have to decide at the moment. Again, another high-level answer, you can later decide what policy you can apply to the data. I cannot give you a specific answer, so that's still a kind of a very good research area of how to properly decide or how to properly define such a policy, or what is the flexible way to define a policy for the data access for different parties at different granularity. So there is a paper that tried to open the direction, like with a schemata approach, giving different access for different people, for different namespaces, in different granularities. But there are still many open questions. Okay, I have exactly 6 minutes. Let me decide what I want to show you. Okay, let me show you the next, this picture, and I'll continue looking what I was trying to show. Okay, so just to highlight, with this slide, I was just trying to highlight that IoT is a kind of big thing. There's not just like smart home camera, like we traditionally think about IoT, but it's also kind of smart farming. And there's actually deployed solutions to like monitor cows, to create more efficient milk production. So they need to know where exactly, or what time exactly they need to be processed. And the solution right now, the one I was looking in the white paper, is really, really ugly. Like, don't get me started on how they exchange the data and how they actually download data from those devices that are associated with cows. Okay, just a few ideas about data security, data-centric security. So this is what we just talked a little bit. Data authenticity is an essential part of the NDN architecture. It's built in effectively in any communication unit on the network, okay, in any this data packet. But it's also the foundation for the data secrecy. So you have to have authenticity in order to add additional things. I explicitly didn't put the privacy in this picture. Okay, maybe just talk about the privacy in here. So with NDN, there are interesting questions about the privacy or how to define it. So first of all, there is no source address when you're requesting some data. So when you send a request, there is no source address. You're just asking for specific data, and the only person who can track who asks this data is your immediate neighbor by looking at the low layer address, and if he can match this lower layer address to the previous hop to you, then he can figure out. But if from the perspective somebody in the middle of the internet, there is no way you can actually figure out what is happening, who exactly is asking. So that's one aspect for the giving the plus for the privacy benefit. Second, a request for the same data will be aggregated. So you don't even know exactly what is the distribution of the requests. So you may have some inference from the caches, like you can infer, oh, this data is actually very popular because it stays in caches for a longer period of time, but that would be the only thing you would infer. So for the popular data, you would know that it's popular. For the non-popular data, you would just, not popular, nothing more. But at the same time, but given these two benefits, there's no source addresses, there's a request aggregation or caches. There's a question of names. So what I was showing you in the pictures, the names are pretty expressive, and giving you quite a bit of metadata describing what is being requested. And in some cases, it is a problem. And there has to be a solution of some form of a name obfuscation. So if we're really talking about like transaction with the Bank of America, the only thing I would want to network or anybody in the network to see is that I'm sending a request to Bank of America. That's no different from today's architectures. But the rest, I don't really want to be in clear text. So you can have some form of encryption of the name, and you still have the benefit of directing that interest towards any Bank of America process in the server. You can still have benefit of last mile caching, so you can recover from whatever losses in wireless or something, and without revealing information. But this is a very good research topic if somebody interested, especially among the people who are still on the phone. Okay, so but there's also a class of applications when you may still use the plain text name, or not plain text, not that the obfuscated names, which will benefit greatly for the application, or at least don't obfuscate very important characteristics. Such if it's a requesting video or Skype call, you can have a specific tags for this application, saying, oh, this is a video. So the kind of network know and network can apply necessary mechanisms to actually assist. Okay, so I prepared way more slides than I actually was able to talk. I will try to stop. But I have like 30 more slides.
So you can put the slides on your homepage.
Oh, sure. Okay, so slides will be on my homepage. Like there is a presentation tab on my page. I will be happy to talk to anybody who will talk and come to office. Or I will be happy to come to anybody's office to talk.
No, we will be
Yeah, so Alex, if you could just summarize in terms of research topics for students, could you just maybe summarize 1, 2, 3 research topics that you're looking for to work with students right now, if you can?
So there's quite a bit of research topics. Like I used to work in a very diverse set of topics within NDN. Right now, I'm mostly interested in IoT environment and application of NDN to IoT. So the topics that is kind of urgent one is a bootstrapping process. So the node model for the NDN is quite a bit different from IP. In IP, you just have to know IP addresses. But for the IoT node to actually function properly to produce data, it needs to be trusted by the network in terms of the opposite. The node has to trust the network, but that it belongs to like FIU in our school, and that the application running on the node has to have a proper certificates to actually publish data in the namespace. And there's a good question, a good research question, how to exactly achieve this process. A related one is you cannot have everything in band. You have, like, for the security purposes, you have to have some form of out-of-band security negotiation or security channels. And there's a good question of what are proper IT, what are the proper out-of-band channels for security for IT devices. They don't have any controls. They're probably very small and not very powerful. I mean, I really hoping for some creative ideas in that respect. I was thinking of like a supersonic, not supersonic, ultrasonic. Like ultrasound way of doing like proximity, for proximity detection and some form of proximity communication because it's very cheap and can be achieved in an easy way. But other simpler approaches like QR active physically printing QR code would be interesting. So that's a security aspect, but there is also a huge area of how you exactly forward the request in IT environment. What is the proper, like I want to avoid word routing, but I would prefer to use word forwarding. So how to forward, rebroadcast request in kind of in IoT case. There are some good ways of doing this if application is kind of geo-specific or location-specific, where you can actually rely on the coordinates that you put actually in the name of the interest to forward kind of over kind of optimal destinations towards that area. We have played a little bit, but again, that's so far still a small area. Along this vein, I'm blanking on. So the forwarding part. If I get back to the security, there's also a lot of. I just touched a little bit about the confidentiality of the data. We have just started, not just started, but there are some ideas how to approach key distribution for the confidential data. But there's still more research needed in this part, especially for the IoT environment, for the small devices that don't really have too much power to do a lot of public key cryptography, or don't have much power in the first place.
Thank you. That's good.
I mean, there's more things they just like on top of my
Just to
head.
give a flavor, so to speak.
Yeah.
But let me ask about scalability. Yeah, you're saying that most of the path is going to be stateful, which is something that was always a problem for IP networks. And you're saying that everything is going to be based on request and content. And with the number of CDNs, websites, storage service providers, all of this, you're talking about keeping a lot of sessions in a stateful manner. And today the routers are having problems just to keep stateless IP address for destination. So how do you think this is going to work in this NDN network where you have millions of users asking millions of contents and millions squared for the number of paths, and this way you save the configuration?
Okay, so I have a kind of 1.5 answer to this. So half answer, I don't really have a very good answer to your question, how exactly it will happen. That's a question, and maybe beyond just research, including some engineering. But the real answer that I want to give you, we need to start with a small thing. And the small thing is some tractable environment where NDN can give benefit and can be deployed without introducing the complexity. And that's why I'm looking at the IoT environment. And actually, they have a project with starting with the DARPA, where they're looking at the tactical environment to apply NDN to the places where IP simply doesn't make sense. Like you want to get in a broadcast environment some information about the soldiers, You don't want to connect to the cloud, to the control center, and then the control center tell you something, but you just want to assess situation and use the network in that local environment. So in these environments, the problem that you mentioned simply don't exist. So there are not a million users. There is a very constrained number of users or controlled number of users, and there's a maybe even limited amount of data that is being around this namespace.
So is there any effort right now to do some sort of integration between NDN and IP networks that I can have like NDN islands on top of
Yes.
IP
So, sorry, I deleted the slide that was actually highlighting this. And this is the model of, we have an NDN testbed. So this is exactly the model for the NDN testbed. So there's a small islands in the few participating universities, and the FIU will be another one, which kind of talk NDN directly in those environments, and the rest is just effectively tunneled within IP network. So reducing the demand and deploy all NDN everywhere in the network. So, but hopefully with the demand that the so-called edges, like if we can prove that it can work at the edges, we can always come up with some engineering hopefully solution to deploy either really stateful forwarding, or there's actually a few tricks, a few elements that you can emulate stateful-ish or at least forwarding that looks like stateful without actually state. There's a few proposals for that.
So just adding on to that, I'm sorry. So when you talk about IoT, you talk about IoT problem. They talk about practical solutions. Here's a device. Here's something actually can work, and just quickly sort of deploy and you see results, right? That's sort of an IoT world. Logging is driven. It's fast moving. You talk about the NDN. That's like a pie in the sky kind of approach. For the entire internet.
Yes.
Right?
For the entire
I
internet,
understand what you're saying about specific control applications and maybe scenarios, small test bed, and even if you add FIU to the crowd, that would be like 6 to 8 in the crowd. A field, right? So that's what I'm saying. So how do you bridge them? When you write a proposal, whenever say I'm going to actually do NDN and for IoT, how do you actually convince people this is actually going to be a working solution at the end of the tunnel? It's a tough. At least that's from my perspective of thinking that working this too. It's an interesting marriage.
Okay, I would agree with this. So there's a challenge, but there's always a way around. There should be a way around.
Okay, well, we're going to just stop like that. Okay, all right. Any further questions? Okay, let's thank Alex again.
And again, if you have more questions, like I'm happy to talk to you.